Hello, my name is Santiago Martinez, and we're going to be going over problem 5 of exam 3. And in this problem, we're evaluating different problems, mostly focusing around inverse trig functions. So let's start with number A. And we got to ask ourselves a question that when we're dealing with inverse, we should always ask ourselves is what cosine of theta equals 0. So we just rearrange, like what angle, I should say better, is what angle equals 0 when we're talking about cosine. And when we're able to do this, we think back to our unit circle. And there's also important rules to mention here, is if we're dealing with cosine specifically, cosine likes to stay in quadrant 1 and quadrant 2. So very big difference from sine and tangent, which we'll see here in a little bit, but that's just an important note. If it's any other value outside of there, it won't work for cosine. So cosine likes to stay positive, and that's a big reason why. Anyways, we know that cosine of 0 has to be a terminal of sorts, right? Because it's x equal to 0. Specifically, pi over 2 is when cosine is 0, and it's in a region that we like. So we'll put that as pi over 2. Pretty simple. And looking at it from a perspective of a unit circle, again, cosine likes to stay in quadrant 1 and 2. And when is x 0? Pi over 2. So cosine, inverse cosine of 0 is going to be pi over 2. Now, let's look at arcsine. And arcsine is just another way of saying sine inverse of negative 1/2. So we have a fun one here. We have negative 1/2. But again, we ask ourselves what angle or what sine of theta gives us negative 1/2. And, looking at this problem, it might seem a little intimidating, but it's really not that bad. And if you remember your rules, right? So sine loves to stay in quadrant 1 and 4, given sine, inverse of sine, loves to stay in these two quadrants. And so that means we have to look at going backwards or looking at it clockwise, right? So sine of theta gives us 1/2. Let's look at that out of these two. So negative 1/2 is going to be here, which when we're dealing with these kind of problems, we kind of want to be fast. We're super lazy when dealing with these problems. So we want to, instead of talking about 11 pi over 6, we'll say negative pi over 6. And it will give us a y value equal to negative 1/2. So this is going to be equal to negative pi over 6. In turn, it's really equal to 11 pi over 6, but we want to skip and act like we're going this way now. Kind of somewhat similar to the last logic of our last video, but not quite. Again, though, we do follow the simple rules of we're wanting sine, so we want the y value here, and that's negative 1/2. Let's talk about our next problem, which is a fun one as well. We have cosine of 3 pi over 2. So the cool part about this is that instead of diving first into this, we dive first into this value. So we know cosine is x. So cosine of 3 pi over 2, what x value gives us 3 pi over 2 is the question that we're going to search for. So let's take a look at our unit circle. And do we have a value of 3 pi over 2 on our unit circle? Yes, we do. It is a terminal. So it's 0, negative 1. And our value there for x is 0. So this equals 0. Nice. So now we have tangent, inverse of tangent, of 0 gives us what? So when we write this, we'll write it as tangent of what angle gives us 0. Right? Pretty simple enough. And when we're thinking about this, what can possibly give us 0 on a terminal? Which will have to be a terminal, And in order to get 0, we have to divide something by 0. So looking at this, what value on this unit circle will give us 0? And it has to be 0 divided by 1, right? Because we can't divide anything by 0. So 0 divided by 1, and we're talking about tangent, should be sine over cosine. So let's find a 0. 0 divided by 1. or excuse me, here it is, right here. Right, because we have sine divided by cosine, so it'll be 1 divided by 0, so this one actually won't work. This one will have to work because we have 1 divided by 0, because this is sine, and this is cosine. That's sine, and this is cosine. But there's a big underlying issue here, is that tangent, specifically tangent of inverse tangent, right? So tangent of this can't really happen, so we're going to put undefined. And the reason being is that there's a rule that tangent likes to stay in quadrant 1 and 4, but does not want to be on a terminal. So when we're talking about that, it will not be on a terminal. So this will be undefined. Or you can just simply write it as tangent of 0 equals 0. But I like to say it's undefined because that's what it is. You can't have that value at all. So that, and then you would have to prove that way. So that's exactly how you do those 3 parts to that problem. And thank you so much.